Okay, this is a tutorial on acceleration. So let's look at a few acceleration problems. So we got a car starting from rest and accelerates to 20 meters per second heading in due east in a time of 5 seconds. We want to know what the acceleration is. So the acceleration is equal to the change in the velocity over the change in the time. So that's going to be the final velocity minus the initial velocity over the time it took for it to accelerate. And then so we just plug in the initial and the final. So we're going to say 20 meters per second minus, no, it says from rest. That means it wasn't moving initially. So that's 0 meters per second over the 5 seconds it took to accelerate. So that's going to be 4 meters per second squared. And that would be your answer. Now in the next problem, the car is slowing down because we're hitting the brakes. The velocity drops from 20 to 10 meters per second over a period of time of 2 seconds. We want to again know the acceleration. So the acceleration is equal to the change in the velocity over the change in time again. So now the final velocity is 10 meters per second, so it's going to be 10 meters per second minus the initial 20 meters per second divided by 2 seconds. So it'll be a negative 10 meters per second divided by 2 seconds, or a negative 5 meters per second squared. Notice the acceleration is negative because it is slowing down. There's nothing wrong with an acceleration or a velocity for that matter being negative, as it just indicates the direction. And since the acceleration is opposing the direction of motion, it is a negative value. Now, here's something with the equations of motions, but still using constant acceleration. In this case, we have a car traveling east, velocity 10 meters per second. It accelerates for 6 seconds at a rate of 4 meters per second squared. We want to know the velocity at the end of that time. So for part A, we need to use our velocity equation of motion. So our velocity at the end is going to equal v0, which is our initial velocity, plus at. So then we plug in, we start off going 10 meters per second plus our acceleration of 4 meters per second squared, and we accelerated for 6 seconds. And then what you have to do then is run that through your calculator. So we've got 10 plus 4 times 6. And so you're going 34 meters per second. Now for B, we want to know how far does it travel. That's our other equation of motion. So the distance it travels, d, is going to equal what? The velocity, 0, times t. So velocity times time will give us distance based on the initial velocity, but we need to adjust that for the acceleration. So it's plus 1/2 at squared. And that gives us how much the distance will be bigger or smaller than that based on the acceleration. In this case, we're accelerating And so we should be speeding up, so that distance should get bigger. Regardless, we plug in 10 meters per second times 6 seconds. Those units cancel. Plus 1/2 the acceleration, 4 meters per second squared, times 6 seconds squared. Make sure you square it or you will not get the right answer. But then the seconds and the seconds squared end up canceling. You're going to run that through your calculator. So 10 times 6 is 60, plus 1/2 times 4 times 6 squared will give you 132 meters. And that would be the total distance traveled. So I hope this was helpful. You can let me know if you have any questions.